Okay, so today, let's hope that our video manages to run the whole way without having to restart and re-record. Looks like today might be a better day. That's great. Hopefully you're all doing okay. I haven't heard from pretty much anyone for a long time, so please correspond with me through email. I know that you're probably catching up as you can, which is fine. As I said before, I'm going to keep streaming. I'm not going to stream every day. I'm going to stream maybe about 3 times a week. And then the other 2, I'm just going to have a work class. So I'm not going to be online streaming. I'll just have an open Google Meet and you guys can just pop in and do work as you need, or just pop in and ask me questions. You can also ask me questions over email. I'm going to continue going on with this applications of linear functions today, but I'm just going to do examples 1 and 2, and then I'm going to assign 2 questions. And again, I know some people are a couple of weeks behind where I am now, and that's fine. You're just going to work at your own pace. We've got a lot of time till June. So just do what you can when you can. And if you have to ask, if you want to ever pop on in a Google Meet or over email, please be assured, like, you can ask me questions from homework that I assigned a month ago or 2 months ago, right? I recognize that everyone's working at their own pace. So let's take a look at example 6. This is the last assignment or last lesson in this unit. And then we're finished talking about linear functions for a while. And once again, a linear function is the graph of a straight line. The reason we're interested in graphing linear functions is to make predictions. And not everything that we study in math or science would result in a linear function. There are only certain situations that result in linear functions. And that's what this book is about. In our next booklet, we'll be talking about quadratic functions. And that's different phenomena that we observe in our world, or different relationships that we study result in a quadratic pattern. This package was just about linear patterns, okay? And even among linear patterns, we saw that there were linear relationships, positive relationship, in a negative relationship, and then just in a flat relationship. So this is basically a summary. So it's nearly nothing new. We're just summarizing everything we've done with linear functions. So we're going to be given information about linear functions with an equation. We're going to be doing some back with the table of values. And then we're creating our own table of values. So again, we're going to take it slow. I'm just going to do the first 2 questions and just keep reiterating and going over the characteristics of the things that we've learned about linear functions. So the first type of application is we're going to talk about one with the equation given. Now, at this point in our learning, I'm hoping that you can recognize a linear function. A linear function, generally speaking, has 2 variables and 2 numbers. One of the numbers attached to the x component, and one of the numbers is just a constant. So linear functions with the equation given. So I'm just going to write this down. Remember, the generic, general sort of mean the same thing, right? They share a lot, that first prefix. Form of a linear function is, this is the form your calculator uses, right? Y equals ax plus b. So it has 2 variables. We need 2 variables to put it on a coordinate system, right? A Cartesian coordinate system. So we have 2 variables, and these 2 are numbers, okay? So the y and the x, y and x are variables. Okay. The a I wonder if I have a different, I'm going to use this. A and B will be numbers, right? There, I have an A and a B. A is a coefficient, so A, put Y and X are variables. A is a coefficient. And the last one, B, is a constant. So we learned all those terms when we did a quick review of our polynomials back at the beginning when we were still at school. So if you have a math equation given to you, and it has two variables in it and two numbers, one of the numbers is a coefficient and one of the numbers is a constant, you know this will result in a linear equation. When we graph it, it'll be the graph of a line. And then that means there's a linear relationship between the two sets of data. So Maya is making necklaces for a craft fair. It costs her $2.50 to make each necklace, and she needs to pay $49 to rent a table at the craft fair. The situation is modeled by the following equation. C equals 2.5n plus 49, where n represents the number of necklaces made. That's why they used n, right, to stand in for necklaces. And C represents the total cost, C standing for cost. Now that's why they change the variables up in every situation, in every word problem, not to confuse it for students, but to make it representative of the situation. It actually helps you understand the math a bit more when they change the variables. If we left everything in X and Y, it gets a little difficult for students to remember what's X and what's Y and what they all stand for. This keeps everything clear in your head. So your job as a student is to look at the two variables they gave you, figure out which one is X, which one is Y. Well, the X value, the one on the horizontal axis, will always be the one attached with the coefficient, right? So instead of an XY axis, we're going to have an NC axis. And right away, that gives you what your labels are, right? C stands for cost, and it's dollars. And N, it doesn't really have a unit other than necklaces, so I'm just going to put down number of necklaces. That's what N stands for. The question will tell you, right? N represents number of necklaces, C represents cost. Okay, sketch a graph of this function. Remember to use labels and appropriate scales. Okay, I've got my labels. Now I need to use my, I'm going to have to use my, my ruler to get an appropriate scale. So let's just take a look though. First thing I want to do is put all this into my calculator to figure out what my graph is going to look like. Now, when your equation is given to you in this generic form, remember you also know a lot more about the situation than maybe before you started studying this. Remember, this is also the y-intercept. In this case, I guess I should call it the c-intercept, but what I'm going to do is I'm going to turn my calculator on, and I hope you can see this. I put a light on my calculator to make it a little brighter for you, and I hope it doesn't blur the page. So I'm just going to try this. So second plus sign number 7, I'm clearing my calculator, number 1, and then number 2. I'm going to try that one more time. Number 7, number 1, number 2. Okay, so everything's reset. All right, now this time, remember there's two ways I can graph a linear function. I can either enter all my data in using the stat edit, enter my table of values in, or enter my equation in. Well, I only enter my table of values in to get an equation. This time they gave me the equation. So I'm going to enter in 2.5x plus 49. Now, just to repeat myself, even though this example gave me things in terms of C and N, my calculator only recognizes Y and X, so that's why I have to adjust when I put it into my calculator. And remember, this is my y-intercept, so I think my windows are going to have to be adjusted. I press graph, and I don't see anything. That doesn't surprise me, right? Because my y-intercept is 49, and I know this is a positive linear function moving upwards. So I know that my graph is going to look something like this, and it's only going to start at 49. That means I have to adjust my windows, right? And I'll just show my work here for windows because that's probably the most important part, right? It's a piece of cake to enter this into the calculator. It's just figuring out what your windows will be. So we need X min, X max, Y min, Y max. They've set me up to be a quadrant 1 graph. So that means they've kind of told me in a way to start at 0 for X min, Y min. So that's what I'm going to do. Now my X max, my y-intercept starts at 49, and this graph is going to be positive going up. So from 49, I'm just going to get bigger, right? So I don't know. I think I'm going to do, I don't know, 200, 250. And I can always change that, right? X max, I said just let's leave the X max until we get a little, because we'll see part of the graph if we do this. So let's do our windows. Just move it up a little bit. 0. I'm going to leave that for now. I've tended to leave my X max until I take a first look at the graph. And then I'm going to put 250 here. I'm putting 250 because she's starting at $49, right? But she's going to move up. I'm going to be optimistic that she makes lots of money. Okay. When it has this little choppy graph, that means you need to increase your X window, right? So I'm just going to read the whole question. I'm going to be smart about this. Sketch a graph. Remember to include axes. Part B is find Maya's total cost if she plans to make 200 necklaces. Okay, so if she's going to make 200 necklaces, my N has to be at least 200. So I'm going to put 250 here. I don't often match, but I'm going to put 250 in for the X value too. Okay, and there we see this nice big upwards line going up. Okay, so, and it says make scale. So I'm going to just make a little scale here, right? I'm going to go 25, 50, 75, 100. Okay, and so 49 is going to be right here. And then I think I'm going to go, okay, so 50, 100, 150, 200. Let's go. Okay, so I'm going to go 50 necklaces, 100, 150, 200. Even though I made my calculator screen 250, I'm just going to do my scale at 200. Now, in order to plot this properly, here's my scale and I move up, but I need one more point, right? So I'm going to include one more point, maybe where X is 100. So I'm going to figure out, there's a couple ways I can do that. I can just go second trace value, X is 100. So Y is 299, right? So that would be, I'm going to have to go a little higher, right? 100, 125, 150, 175, 200. It's going to be off my grid. I think I'm going to knock it back a little bit. I can't graph that on my grid, so I'm going to see where X is 50. Second trace value, figure out where X is 50, Y is 174. Okay, I can graph that. Okay, so when X is 50, 25, 125, 150, 175. Okay, so remember I'm trying to graph the point 50 and 174. I want to make sure my graph is accurate, right? That's why I'm being precise about this. So 50, 174. So 50, 174 is about here. The reason I want to identify another point is I want to keep my slant accurate, right? And notice I'm going to put an arrowhead here to indicate that profits are only going to go up. Okay, so there's my graph. Now I want to show you another little trick. I did mention this in a previous class, but when you're doing another way, I can always figure out a coordinate point by doing second trace value, and I can put anything I want in for X. Like what if I put 80 in for X? Oops. Okay, 80 necklaces would mean that the cost would be $249, right? So that gives me, I could have graphed X80, Y249. So X80, Y249 if my graph would have gone that far. But a really quick way to graph, once you have the equation, as soon as you enter an equation into a Y equals, your calculator automatically sets up a table of values. And right above the word graph is the word table in blue. So if I press second graph, I'm going to get a table. This gives me all the coordinate points on my line, right? So I didn't even have to go in and make a special X value. I could have just plotted, let's see, I could have plotted when X is four necklaces, the cost is $59. So I could have gone like 459, right? I could have found a point that way too, just as a little point of interest. Whatever you find easier. Either using the second trace and just pick any value you want for X, right? X is 50, so you'll get 174 that way. Or you can go to the table. So the table will always be there if you put an equation in. All right, so we've done that. Sketch a graph. Remember to include label, appropriate scales. Okay. Labels, scales, a couple of coordinate points. Okay. Same technique using graphing calculator. Okay, well, let's see about that. So basically they're saying find C, find the total cost when N equals 200, right? Now that would be over here, and you can see the limitations of a paper graph. I'm limited to what I made my scales. Also, even if I would have done a graph, a really big graph that would have included 200 and my Y graph would have been that high, it would have been really hard to read the exact value, the exact answer off the graph. That's why technology is nice. So remember, what we're doing here is finding Y when X equals 200. Right? We've just renamed our Y as C and our X as N, but the calculator doesn't know that. So remember your technique? You're just going to go second trace value. That's your first option, 200. Okay. So clear out of here. Second trace value. I want X to be 200, they said. Just double check that, yeah. And Y is 549. Okay, that was easy. Y is 549. Now I can't leave it like that. It says find the cost if she makes 200. So the total cost is 549 for 200 necklaces. Now remember, your calculator calls everything XY, but the question itself didn't talk about XY, so I just have to translate into words to answer the question. So if it was a word problem and the question was posed to me in words, I have to respond in words. Okay. I'm going to do one more example. And then I'm going to call it a day. And then tomorrow I'm just going to have a Google Meet if you guys want to talk. So example 2, another equation given. Okay, so we know how to handle this. I'm going to clear my calculator out first. Second mem, 65 subtract 8.5x. subtract 8.5x. Remember your calculator. Usually I put the, or in general form, this is what it would be, right? In generic form, plus 165. Your calculator recognizes it as anyway. It'll recognize that this is the leading coefficient. That's the constant. Remember, that's my y-intercept. So once again, my y values are going to have to be very much bigger than just 10. So let's talk about this. I'm just going to do my x min, x max, y min, y max. They've given us a big hint here. It's a quadrant 1 graph. So x min and x max could start, or x min and y min can start at 0. And that makes sense because we're talking about money and weeks and time. So let's do this first. And I'm leaving my x max till I take a look at the graph. Now this is a graph of a linear function with a y-intercept of 165 descending. So I don't really need to go much higher than 165. So maybe I'll just do 170 for y max. So 30 fits. And let's see if I read ahead to the question. I've got 5 days, 30 days. Maybe I'll make it a little bigger than 30. I think I'll go 40. There, okay. I was just reading ahead to make sure I don't get an error message on my windows. So I'm going to do 40, sketch the graph. Okay, so this is my y-axis is now an L-axis. X is known as D. And let's see, D is number of days, right? Once again, pay attention to how you okay, so sketch the graph. I could sketch the graph just using intercepts too, by the way. So if I just use intercepts, I know this is going to be 165, right? These graphs are a little easier to sketch because you have 2 intercepts. So a descending graph will have intercepts. Let's just double check our intercepts. Remember that second trace value. Put a 0 in for x. And sure enough, I get 165 for y. Let's find the y-intercept now. y2 is 0. Then I'm going to go second trace, number 5. Okay, I need to find my cursor. I don't know where it is. Okay, I'm looking down here as a clue. It's telling me that y is negative. Well, no, I gotta move my cursors. Okay, there's my cursor. I finally see it. Okay, and you can use these as hints, right? So first curve, yes. Second curve, yes. Take a guess, yes. All right, my x-intercept when y is 0, x is 19.49. So I'm just going to make a little, I don't really need to worry about a scale really if I just use intercepts, right? 19.41. Okay. So once again, if I just press graph, that's what I'm graphing here. So I'm just going to take my ruler. Connect my, okay. All right, so sketch the graph, state the domain and range. So I've got labels, I've got units, I've got, your graph has to have at least one number on the x. Okay, so I've done that. State the domain and range. Okay, so let's see, the domain is all the information on the x-axis, right? The x value. So the domain would be the number of days, the set of numbers that, all numbers possible in the number of days. And then the range is the money, right? Amount of money. Okay, so if I see, this is my graph, right? My graph runs from here to here. This is the domain, right? From here to here, all these values are members of the X because the graph only consists of this chunk of the line. The X coordinates on this chunk of the line would be from 0 to 19.41. So this is another way I can show the domain, 19.41. So the domain is from 0 to 19.41, and I use square brackets to indicate that's the domain. Or another way to show the domain is the range. So it looks like the Y values start at 165 and go to 0. So the range would be from 0 to 165. Or 0, 165. Y is between these two numbers. Okay, so that would be the. I know we said lines, general lines have domains and ranges of all real numbers, but this is a real life situation, a word problem. Word unrestricted domains and ranges. Because once again, I can't have a zero amount of dollars or a negative time. So how much money does he have after 5 days? Okay, well, if I was trying to read that off my graph, it would be very difficult. 5 is about here, right? But I have no clue really what amount of money that would be. So we're going to use technology. Second, trace value. Okay, so I'm going to go second trace value. It wants X to be 5. So Y equals 122.5. So in context, I can't just leave it like this because a casual reader might not understand this. I would have to say Ahmed has $122.50 left after 5 days. Now, how much money after 30 days have passed? I think this is a bit of a trick question because it looks, according to my graph, he runs out of money in 19 days. At 30 days, there won't be anything left, right? So second trace value. Let's put X equals 30. I'm not sure what's going to happen. I have a feeling it's going to give us some bogus information. It says negative $90. So that's not really possible in context. So we have to be really aware. Answering negative 90 would be incorrect because the bank is not going to keep giving you money. So, or his bank account would have ended at 0, and that would have been it. Y equals negative 90. Okay, not possible. Ahmed runs out of money in 19.41 days. So after 30 days, he would be out of money. He would have no money left. So here's a big deal question coming up. This is something new. When will he have $100 left? Okay. This is tricky. It's very easy just to figure out how much he'd have after a certain number of days. But when will he have $100 left? This is the same as find the X value when you know the Y value. In this case, we're finding D's and L's, right? This is the same process that you used when finding the intercepts of functions. What we do is we enter a second equation in. Okay, so what I'm going to do is I'm going to enter a second equation, 100, right? If this is where 100 is, I'm going to put a second equation in my line. So I'm going to put, I already have my Y1 statement. My Y1 statement was, remember my Y1 statement was negative 8.5x plus 165. Now I'm going to enter y2 equals 100. And I want to find this intersection point, because this intersection point will give me the x value when y is 100. So I'm just going to put a little star here. So it's the same process we used to find the y-intercept, or pardon me, the x-intercept. I put a y value of 0. Now I want a y value of 100. And whatever value it gives me for x will be the answer I'm looking for, okay? So once again, this is the same process you use to find x-intercepts, except instead of doing y2 is 0, I'm going to do y2 is 100. And then we'll use the intercept. Okay. So I go to my y statement. Remember I had this y2 equals 0 just to help me find the x-intercept. Oops, sorry. So I went to my y equals screen. I want to get rid of the 0. Now instead of 0, I want y to be 100. Now this time you see a horizontal line moving across. That actually happened here for your x-intercepts as well, but you didn't see it because it was lying on top of the x-axis. So I'm going to do the same process, second trace, number 5. Answer 3 questions. Yes, yes. Actually, I'm going to move it closer, a little bit closer. Take a guess. And sure enough, when y is 100, x is 7.65. So x is 7.65. Okay, so when y equals 100, x equals 7.65. So when will he have $100 left? In 7.65 days, because that's what x represents in this question, Ahmed will have $100 left. Okay, so I'm gonna stop there for today. I don't see anyone chatting with me today. Remember, you can always live chat. I'm going to leave it there. I'm going to post these notes tomorrow, just a work class. So I'm just going to open a Google Meets, and you can either work on your own or hop in and ask me questions, but I'm not going to do anything new tomorrow. So please hop on and ask me any homework questions you might have from the past or anything you're working on. I'm here to help. Okay. It looks like Google ended up recording everything fine, which is great. So hopefully this video recording will be able to be played back for you, and I look forward to talking to you guys soon. Okay, bye.